Machine learning technologies and artificial intelligence, and also their application in information security, will be the topic of the next presentation by Vyacheslav Gordeev in Form Защита. Vyacheslav. Hello, dear colleagues. Alina, thank you for introducing me, but I'll correct you. My name is Vyacheslav Gordeev. I'm just a systems engineer at Fortinet, but no big problem. Today we're going to discuss quite a sophisticated and complicated, but an important and exciting topic about using machine learning and AI in information security. Let's first do the main terms. Artificial intelligence, machine learning, deep learning, neural network. These terms are sometimes used as mutually replaceable, but of course they mean different things. Artificial intelligence is the top-level concept, meaning that the computer can execute sophisticated tasks that traditionally required human intelligence. Machine learning is a type of artificial intelligence where statistical models can take decisions or make forecasts without pre-programmed logic rules. Deep learning is one of the approaches to machine learning, where algorithms that used to be linear in machine learning now comprise sophisticated hierarchies with layers. Because deep learning and other multi-level systems work in a distributed way, but in an interrelated way, just like in a human brain, these systems are called neural networks. Let's make one step forward and sort it out with the known models of artificial intelligence. Firstly, let's define AI. It's a capability of a machine to assimilate the reasonable behavior of a human. There are different models: machine learning, artificial neural networks, and deep neural networks. Machine learning uses data to find out how computers make predictions or execute tasks. In this example, we teach a machine to recognize letters of ABC, to classify, to recognize the word B. Imagine we have data about 10,000 fish in a fish bowl, and we know everything about each fish, if it's carnivorous or not, how many flaps it have, what other types of fish it can coexist. Also, we know the cost to keep each fish in the fish bowl. So our task is to find out how much it'll cost us to maintain the fish bowl.
Artificial neural networks are more complicated than machine learning. ANN is usually defined as a system of hardware or software designed to emulate the way the human neurons work. Well, for example, this is how you will, say, teach a machine to identify various categories of bees. So this type of a neural network will be smarter. It will be able to identify certain properties of the object. That was, well, the main gist of a particular training dataset. Deep neural networks are the most complicated form of AI. It is an artificial neural network that has more than two or more layers, It is used to model complex non-linear relations. For example, you can teach a machine to identify various types of bees, time of day, and countryside versus city. Deep neural networks use layers of use various layers to imitate the abstract thinking of humans, as well as our capability to generalize. For example, A neural network can be taught to identify various handwritten letters, but a regular artificial neural network will need to be taught all types of handwriting. Not so with DNN. Now let's look at examples of using AI and ML in information security. Well, first and foremost, I suggest we look at how we can use AI in order to identify and rate websites and IP addresses. Since 130 to 150,000 new domains are registered every day, it is a critically important side of cybersecurity. It's important for a company to know which websites are to block, which may contain harmful content, and so on. As the slide shows, information on new websites may come from various sources. This could be databases or DNSs, or it could be, for example, the WHOIS database. So there are lots of different potential sources. When you have this multitude of sources of data, we are talking about millions of events, and it is impossible to process them manually. There are numerous models of artificial intelligence that will come to your aid. Let's look at least at some of them. One is ANN, Artificial Neural Network. So they are used, for example, for DGA, Domain Generation Algorithm-based websites. And they will also be talking, for example, to the event logs, which helps them identify potential botnets. Next is Markov. Markov-based algorithms will identify dangerous websites based on structural similarities of website addresses. So it is effectively based on a computation of a qualitative coefficient based on which a verdict is passed on whether it is a potentially harmful site or not. Next one is logistic regression. A logistic regression will look at a bunch of addresses effectively, and it will make a forecast of the probability that a particular website is a bot. Next one is a KNN classification, K nearest neighbors method. It is actually one of the simplest and at the same time most efficient types of machine learning. However, it is very slow. What it does is classify URLs based on a formalized label such as domain, link, URL parameters, and so on, other metadata. So some IP addresses and meta addresses will need to be analyzed again, particularly those for which the model has not given a decisive response. So what we usually get is a set of rankings for, various rankings and threats contained therein. Another problem deals with the analysis of the numerous files as you are trying to identify the harmful ones. Just like in the previous case, you cannot manually process all the files coming for analysis by the analytical center. That's why it's so important for modern security systems to be able to automate this task as much as possible. Given that analysis of a single file may easily take 10 minutes to several days, it is obviously a very pressing concern. In order to address this, there are several triple-layer neural networks. Actually, you can have more layers, you can have fewer, and you can have different structures of these neural networks. I'm just showing you a single example here. So, as an input, you use a file. Then you have a malicious layer, which will look at billions of good and bad attributes at the same time, developing, a sensible assessment of whether it is a malicious file or not. And then, based on an automated rating, it will develop and distribute new signatures and indicators of compromise. Same actually applies to sandbox class of devices, which are usually used to identify, detect previously unseen threats. And it is usually done in an isolated environment emulating a workstation with a real user. Since many data leaks are related to exploits of web applications as opposed to installation of malware, protection of web applications is a key concern, particularly if your business as a company is directly related to the web. Web technologies are actually some of the fastest developing in the world, and since the surface attack here is much bigger, there is, a much bigger perimeter to defend. What they all have in common is that just like with filtration of IP addresses, here we need to filter requests as well as responses to the queries coming to the web application. That's why many companies have deployed web application firewalls. However, given that there is a minor difference between an exploit and a targeted attack, these solutions have always required a lot of fine-tuning. That's why it is so topical today to apply machine learning in order to protect against 0 days. Because here you have a smart discovery of threats with very low level of false positives. Let's look at a particular example here. It's a 2-layer network. Layer 1 will discover anomalies by developing a profile and a mathematical model for each of the parameters in the system. So for each of the requests, we will calculate mathematically a number of values based on statistical indicators as well as on the basis of the data being transmitted. So this gives you a tree structure. Layer 2 will classify the anomalies as threats or otherwise by looking for specific attributes based on certain thresholds, based on pre-trained models developed to identify certain types of attacks such as XSS, SQLI, and so on. As you apply this model, configuration and maintenance of web application firewalls becomes much easier. The endpoint, be it a server or a workstation, is very often the end target of many attacks. And since managing all those vulnerabilities on the network and off the network can be quite difficult, it is only natural for us to deploy ML-based and AI-based protection systems around endpoints. Modern problems require modern solutions. For example, we can use EDRs together with anomaly detection-based machine learning systems. For example, they can be a good complement to next-generation antivirus systems. They can help you analyze anomalies, identify threats, say in the cloud storage, and they will also enable you to minimize and liquidate threats without quarantining the whole device. ANNs are also used to automatically classify threats and automate the correction process, or, well, the incident response, if you like. Naturally, not all the threats come from the outside. The insider risk is a considerable concern. It actually keeps growing. This problem will continue to exist, and there are numerous hardware-based solutions, but most of them are actually, let me rephrase that. Some of them are learning to apply AI in order to identify threats. So machine learning can be used in order to develop profiles for normal behavior of regular users, and therefore, over time, learn to identify anomalous behaviors, which is often correlated with insider risk. So this is user and entity behavior analytics class of systems, which will do continuous monitoring of what the employees are doing based on ML. So they will be watching their manipulations of files, servers, data flow, and so on. And once something suspicious is identified, it will inform information security professionals, thereby kickstarting their investigation. And the main objective here is to minimize the risk of leaking critical data while also increasing the overall security of the organization.
Сосредоточившись на операциях по обеспечению безопасности,
Having focused on security assurance based on AI, we will see the usage of machine learning and other expert systems can pretty much guarantee that the organizational security is, well, abreast of the modern threats, even if you don't have enough cyber skills, for example, which are the pandemic, the main pandemic for this industry. Actually, as you embrace new systems based on ML, you will start looking for the right vendors. Because the thing is that, vendors first develop general systems and then they will scale them out to cover various verticals.
процессы и обработка данных в компаниях
Please note, however,
решений по ИБ требует времени. Поэтому
that it
многие
takes quite a lot of time to customize systems like this, which means that many targeted threats may actually reach your company before the labs do anything sensible about it. That's why many large customers deploy their own labs or create their own labs to do similar ML projects. And they can actually beat global analysts to discovering certain threats. So if we look at the kill chain
каким атакам, то существует
and discuss how we can actually thwart various attacks, we will see the following. There are, for example, deception-based
объекты могут
systems
потенциальные соединения
which can help you detect a potential first recon contact, so to speak, and your
на этапе даст
machine learning will tell you that this is the first stage of an attack. At the stage of delivery of a potentially malicious code, sandboxes can be used.
уровня доставки угрозы.
Actually, sandboxes will be very useful all the way from delivery to exploitation, installation, and connection to the command and control center. You will also be using WAFs and EDRs. And the last stage, when the threat has already materialized,
Донос соединился с
when a malware has connected to CC,
анализируя поведение
we will have a system analyzing user behavior.
Это именно
And this is the last tier of our defense, which also can rely on machine learning.
атака злоумышленников есть
Here,
интересная особенность. Мы
adversaries' attacks have a peculiar feature.
машинного обучения.
Or rather, we have a peculiar system to thwart them by using ML. However, adversaries can also use ML in their activities.
Своих злонамеренных деяний.
To commit their nefarious acts. I guess the most interesting fact here is that AI models can be applied to, for example, collect information about a particular person or a group of people online. Also, they can automate data collection on the group of companies. They can also be used to collect information offline. For example, we are talking here about security people carrying radios or people using cardio stimulators, pace setters, and they can also use ML to deepfake voices or faces, or to do brute forcing, or to bypass capture, or to search for vulnerabilities, or even develop malware. Actually, ML can be used to create new signatures of malware, and that's a major subject. Actually, in closed networks, very often you can deploy a novel type of malware which will go undetected by EDRs, AVs, and what have you.
Решения, которые позволяют, в принципе,
So there are tools for that as well.
запросы контролировать, доставку такого вредоносного ПО тоже можно блокировать.
You can automate delivery of malware, but then you can automate blockage of such delivery as well. So let me summarize by saying the following. Usage of ML models opens, lots of opportunities in the cybersecurity industry. The most important question, however, deals with the verification and even veracity of the input data, the quality of input data. That's the mother of all problems, because the input data tends to contain so much noise.
И так далее. То есть невозможно построить цепочку, которая бы
It
подтвердила,
is
что действительно это
often very difficult, if not impossible, to develop a chain of events, a linking, a kind of constructing a whole incident.
разрешить, ограничить и отслеживать
Security policies enable users to limit and track network traffic on the basis of the behavior of individual users or a given application. At the same time, rules and policies used in most security systems are static and they are based on ontologies or human experience. That's why automatic creation of rules is an interesting subject to look into. Usage of hybrid methods.
продуктов в области
Most commercial products in the field of cybersecurity will contain various signature-based methods for detecting intrusion. This is true for AVs, this is true for IPSs, and so on. If you actually combine deep learning with machine learning, you can actually increase the efficacy of your systems designed to provide cybersecurity.
использования модели ИИ это
Finally,
не
usage of AI is certainly no silver bullet. It does not guarantee proper protection of your data, but it can be a good complementary tool,
компании или
making your company a bit more secure.
У меня все. Всем спасибо.
I'm done. Thank you very much.
Спасибо большое, Вячеслав. Очень познавательно было.
Thank you very much, Vyacheslav.
С нами был
Let me remind you
системный инженер Fortinet
that we've been hearing from Vyacheslav Gordeev,
Всем за внимание. Мы продолжим.
systems engineer of Fortinet. Thank you very much. We'll continue after a break.